Hello and welcome to today's lesson on element formation, which is part of the space physics topic in GCSE Separate Science physics. So in today's lesson we're going to describe when different elements are formed in the universe. So if we've been successful and learned in today's lesson, we should be able to describe the conditions where elements from helium to carbon form, describe the conditions where elements from carbon to iron form, describe the conditions where elements from iron to uranium form in detail where all the different elements on Earth first formed. This links in the following part of the GCSE Separate Science Physics Specification 4.8.1.2, the life cycle of a star. Now, stars are extremely important as they're the one place in the universe where fusion happens naturally. So this means that stars are the one place in the universe where new elements are formed. So every element larger than hydrogen has been formed in the cores of stars. So without stars, the universe would be a mixture of hydrogen and helium due to the Big Bang. So hydrogen and helium was formed at the Big Bang at the start of time and space itself. Hydrogen can turn into helium in the core of main sequence stars via nuclear fusion. All elements up to carbon or oxygen are formed in smaller red giant stars, whilst all elements up to iron are formed in larger red stars. Now this is both by the method of nuclear fusion. And finally, every element from beyond iron is only formed in a supernova explosion. So this means that every element in your body, with the exception of hydrogen, was formed in stars millions of years ago, and there's part of you that was actually formed in a supernova explosion. So when you consider the elements found in your body, you could either consider yourself as stardust or as radioactive waste, depending on your point of view. So if the solar system and life itself on Earth did not form from the remnants of a supernova explosion, our periodic table would look very different. Because as every element above iron is formed in a supernova explosion, it would mean the heaviest element we would know would be iron, which would make our chemistry lessons a lot easier, but would make life a lot duller. So if we didn't have the remnants of a supernova explosion in our solar system, we would be missing the following elements from our periodic table. So as you can see, there's a lot fewer elements formed in the cores of red giant and main sequence stars as opposed to that of a supernova explosion. So we can consider yourself as a universe, as it's just the universe is expressing itself as a human for a little while. So let's just consider this in the life cycle of an average star. So in stage 1, the nebula, hydrogen and helium are present here, and it's still the same idea when you've got your protostar. But at stage 3, the main sequence, hydrogen is fused into helium, whilst at stage 4, the red giant stage, fusion of elements up to carbon occurs here. Remember, a red giant for an average star doesn't have the temperature or pressure to fuse elements any higher than carbon. Then what happens is when you get to the white dwarf stage, no fusion of elements occurs here, or neither at the black dwarf stage, because fusion has stopped. But let's now consider the life cycle of a larger star. Once again, in your nebula, hydrogen and helium are present, then they're present again in the protostar, but then in the main sequence star, like in an average star, hydrogen is fused into helium. But then in our larger red giant stage, in stage 4, fusion of elements up to iron occurs here because the temperatures and pressures are high enough in a large red giant to fuse all the way up to iron. Then you have your supernova explosion where you have the formation of elements larger than iron. But when you get to the neutron star stage or the black hole stage, no further elements are produced here, but it's important to note that the supernova will distribute all the elements throughout the universe to form new nebulae to allow new planetary and star systems to form. So we can sum up element formation in the universe with the following picture. So you've got hydrogen, you've got helium, you've then got the metals which are produced in the processes of red giants, with only the large metals up to iron being produced in the larger red giant stars, and then finally everything above iron is produced in a supernova explosion. So the interiors of stars provide the only conditions in the universe for new elements to form through fusion. So hydrogen and some helium was formed at the Big Bang. Helium can be formed in the main sequence stage of a star's life cycle. Beryllium up to carbon will be formed in an average red giant. Beryllium up to iron iron will be formed in a large red giant, and everything above iron is formed in a supernova. Now, because iron is the most stable nucleus in the universe, it is not energetically favourable to carry out fusion above it, but it's only made via fusion in a supernova due to the high temperatures and pressures present. Now, elements larger than iron, such as uranium, can be found in the solar system, including Earth, which indicates to us that the solar system must have formed from the remnants of a supernova. So we are not in the first cycle of a life cycle of a star in our current solar system, more likely in the second cycle of the particular life cycle of a star. So let's just summarize what we've learned in today's lesson. A star undergoes a life cycle. The life cycle is determined by the size of the star, and you should be able to describe the life cycle of the star if it's the size of the sun, an average star, or more massive than the sun. Now, fusion processes in stars produce all of the naturally occurring elements in the universe, and elements heavier than iron are produced in a supernova. Now, the explosion of the massive star, the supernova, distributes the elements throughout the universe. So if we've been successful and learnt in today's lesson, we should be able to describe the conditions where elements from helium to carbon form, the conditions where elements from carbon to iron form, the conditions where elements from iron to uranium form, and we should be able to detail what all the different elements on Earth were first formed. So I hope you've enjoyed today's lesson on element formation, which is part of the space physics topic in GCSE Separate Science Physics. Thank you very much for watching, and have a lovely day.